Hello everyone. This lesson is an introduction to transformers. Why are transformers so successful and what are the key features and applications of transformers? So let's begin. So first of all, what are transformers? So transformers are advanced AI models specifically designed for natural language processing tasks. And what sets them apart is their ability to use self-attention mechanisms, and this allows transformers to efficiently process and generate sequences of data by understanding the relationships and dependencies within the text. So the revolutionary concept of transformers was introduced in the landmark paper, and it was titled "Attention is All You Need." It was published in 2017, and this paper laid the foundation for how transformers work and highlighted the importance of attention mechanism in understanding and generating language. So transformers have revolutionized the field of natural language processing. They have enabled significant advancements in creating highly effective chatbots, improving language translation systems, and enhancing search engine capabilities. By understanding and processing natural language with remarkable accuracy, transformers have set a new standard for performance in these applications. While transformers have made a tremendous impact in NLP, their influence extends beyond text-based applications. So their application goes to in the domain of computer vision, where transformers are now being used to enhance image recognition and generation tasks. They are also used in music generation, where they are also utilized to create and innovate in the field of music generation, producing compositions that mimic human creativity. They are also used in the field of protein folding in scientific community. Transformers have been applied to protein folding problems, aiding in understanding and predicting complex biological structures. Now, let's see why are transformers so revolutionary. So transformers have revolutionized the field of natural language processing and machine learning for several key reasons. Firstly, the concept of self-attention is fundamental to transformers. Self-attention allows the model to understand and capture relationships within text sequences, regardless of their positions. This means that the model can focus on different parts of the input sequence to understand context and meaning more effectively. Secondly, transformers excel at handling long-range dependencies. So traditional models often used to struggle with processing large sequences of data efficiently. However, transformers can manage these long-range dependencies with ease, making them highly effective for tasks that require understanding context over long text spans. And lastly, transformers leverage parallel processing, which is a significant advantage over previous sequential models. This parallelism supports faster training times and enhances scalability by processing multiple parts of the data simultaneously. Transformers can be trained on large data sets more efficiently, leading to quicker development cycles and the ability to scale up for more complex tasks. Now let's look at some of the key features of transformers. So we have already discussed self-attention mechanism. So transformers leverage a powerful concept known as self-attention mechanism. This mechanism allows the model to focus on different parts of the input sequence regardless of their position, to understand and capture the relationship within the data. Essentially, it can consider the importance of each token in relation to every other token in the sequence. So we will see what tokens are later. So for now, for simplicity, you can think of token as some kind of words, but we will see that there are many forms of tokens. So this enables a more nuanced understanding of context and dependencies. So this is particularly useful in tasks such as language translation and text generation, where meaning of a word can depend heavily on its context. For example, if you have a bank, without context, you don't know whether we are talking about bank which deals with finance like money, or is it a bank of a river. So context is required, especially in tasks like language translation and generation. Next, feature is positional encoding. So while self-attention mechanism excels at understanding relationships within a sequence, transformers also incorporate positional encodings to retain the order of tokens. So this encoding adds information about the position of each token in the sequence, allowing the model to capture not only the meaning of each token but also how its position affect the overall context. And this is very crucial because the order in which words appear can significantly change their meaning. So by embedding positional information, transformers can effectively understand and generate coherent sequences. And the third feature, we will talk about scalability. So one of the standout features is scalability. So unlike the traditional models that often struggle with large data sets, transformers can efficiently handle vast amounts of data and perform complex training tasks. So this scalability is achieved through parallel processing, where multiple sequences can be processed simultaneously, leading to faster training time and the ability to work with large scale data sets. This makes transformers particularly suitable for modern applications that require processing and learning from massive amounts of data, such as large language models and sophisticated image processing tasks. So this was a brief introduction to transformers. In the next few lessons, we will look at tokenization and its role in language modeling. Then we will look at decoding strategies and text generation. Then transformer architectures. So there are different transformer architectures, and like encoder, decoder, encoder only, and decoder only. Then we will look at some of the applications and limitations of transformers. And finally, we will look at pre-training, fine-tuning, and beyond text. So we have already seen that the application of transformers is not just limited to text, but it goes beyond text.